Hello guys, I'm glad to welcome you on my YouTube channel, and in this video we're going to solve an interesting problem about a smart swimmer who wants to swim across a river with minimum shift along the flow of the river. So the problem sounds like this. The boy swims with a speed twice smaller than the speed of the river flow. In which direction the boy should swim towards the other shore so that he is carried by the current as little as possible. Okay, so what do we have? Have a river with some velocity flow of water. Let's call it V. Then we have a boy. Let's draw a boy who wants to cross this river. His velocity is twice smaller than the velocity of the flow of river. And the goal is to be carried by the current as little as possible when he reaches the opposite shore. So somewhere here he will reach the opposite shore, and in order to start solving this problem we need to set a system of coordinates which originates in the initial position of the boy. So this is x, this is y. So here is some x final, where he will reach the opposite shore. So this is the distance which should be minimum. It's the distance by which this boy will be carried, along which this boy will be carried by the water flow, and our task is to find this angle alpha at which his velocity should be directed in order to make this distance xf minimum. So let's first write expressions for the x and y components of his velocity, total velocity with respect to the ground. So it will be Vx equal to V minus V divided by 2 cosinus alpha, and Vy will be V divided by 2 multiply sinus alpha. So is this component of velocity and this one. So based on this we can write V1 minus cosinus alpha divided by 2, and this one we cannot simplify yet, it's already simple. So let's write expressions for x position. It will be V multiply t1 minus cosinus alpha divided by t, and y position will be V multiply t sinus alpha divided by 2. So let us from the last equation define the time, we call it tf, like final time, when he reaches the other shore, and this will be, we will need to take into account d if it looks like D. The width of the river. So I know you may tell me that this problem doesn't give us the width of the river, but now we need it, and later you will see that we will get rid of it. Okay, so this will be equal to D 2D divided by V sinus alpha. Okay, I got it from this equation, assuming that y is equal to D. Good. Now we can get equation for the x final, which is V. Instead of t, we substitute its value tf, which is 2d divided by v sinus alpha. And this we need to multiply by 1 minus cosinus alpha divided by 2. Okay, what do we get here? So we cancel out this v, and our equation is 2d 1 minus cosinus alpha divided by 2 divided by sinus alpha. And let us rewrite it a bit in different way. It will be d multiply 2 minus cosinus alpha divided by sinus alpha. Okay, so like this we got this equation which describes dependence of the final x coordinate of the boy when he reaches the second shore, the opposite shore of the river, as a function of angle alpha, which we need to find. So let us keep this in mind, rewrite it in the next slide, so we have more space to go further. Good. So xf is equal to d 2 minus cosinus alpha divided by sinus alpha. So how do we find the condition or the value of alpha at which x final will be minimum? This is the task of this problem. So from calculus we know that in order to find minimum value of the function, we need to take first derivative of this function and set it to 0. So means that we have dxf divided by d alpha, where alpha is independent variable, should be equal to d capital D 2 minus cosine alpha divided by sine alpha d alpha, and this should be equal to 0. Okay, so in order to take this derivative, it will be more convenient to rewrite this equation as the product of two functions. So it will be d multiply 2 minus cosine alpha multiply sinus minus first power alpha. And now we can take this derivative. So xf prime, which is first derivative of function xf, will be equal. So we have product of two functions, and that's why we need to follow the rule for taking derivative of the product of two functions. So it will be like function u multiply function v. Derivative will be du over d, let's say x, multiply v plus u times dv dx. And keep in mind that this sign is in the minus first power is of alpha is a complex function, so we need to take derivative of its power first and then of sinus itself. Okay, so let's go to the derivative. So it will be d multiply sinus alpha, because derivative of this part, so 2 is constant, cosinus alpha derivative gives us minus sinus alpha, and this minus gives us sinus alpha, times sinus minus 1 alpha, then plus, so this d can be out of parentheses. What do we have here? We have 2 minus cosinus alpha times minus sine in minus second power alpha, and times cosinus alpha. So we took first derivative of sinus alpha in minus 1 power, so it's minus sine alpha in the minus second power, and then we multiply to the derivative of sine alpha, which is cosine alpha. Okay, so here we are done. Let's try to make this equation simpler. So d, what do we have here? It's sine alpha multiply sine alpha in the minus first power, so it's unity, plus 2 cosine alpha minus cosine alpha in second power, divided by, okay, sinus not good, so it will be minus here because we have minus in next to sinus alpha in the second minus second power, so here will be sinus second power alpha. Okay, so let us set it to common denominator, d sinus alpha square minus 2 cosine alpha plus cosine alpha square divided by sine square alpha. Okay, this will be equal, don't have much space here, but let's try to squeeze it in, d. So sine alpha square plus cosine alpha square gives us unity from the course of trigonometry, minus 2 cosine alpha divided by sine square alpha. Looks like we are done with this. So keep in mind this final equation and let's rewrite it on the next slide so we have more space. So it's 1 minus 2 cosine alpha divided by sine alpha square. Okay. So first derivative of this function xf is equal to d. Yeah, and I forgot. Oh, actually 1. 1 minus 2 cosine alpha divided by sine alpha square. Okay, now we got this first derivative, and what do we do in order to define at which alpha we will get minimum xf? We set this derivative to 0. So this derivative will be equal to 0 when the denominator is equal to 0. So because d is for sure not equal to 0. So that's why I told you earlier that we will not need d for our final equation. 2 cosinus alpha is equal to 0. Okay, so which comes from here that our cosinus alpha is equal to 0.5, and our alpha, which we're looking for, is equal to 60 degrees. So that's why if our boy is a very smart swimmer, he will choose the angle between the shore of the river and his velocity vector as 60 degrees. In this case, he will be carried by the flow of the water with velocity vector v by minimum distance x final minimum. Okay, thank you very much for attention. This problem is solved. This is the answer, and I hope to see you guys again on my channel. We will solve much more interesting problems in future.